Hello students, welcome to your channel Sukh Academy EduWorld. Today we will discuss three questions from UPSC Geo-Scientist 2024 exam. That is question number 99, 100 and 101. And in the 99th question, they ask that which one of the following statements is correct regarding the given reaction. And in this reaction, 2-fluorohexane is treated with sodium methoxide and mixture of product is formed, and we have to tell them which is major product. Okay, and in if we see sodium methoxide is a strong base. Actually, this sodium methoxide is a strong base that can also obstruct proton from a hindered position. Okay, so if we consider actually this reaction follows E2 mechanism. Okay, and in this base will abstract proton from this carbon and from this carbon also. Okay, and first of all, if this base will abstract proton from this carbon, okay, these electrons will shift here, and this fluoride anion will leave as a leaving group, and this product will be formed. Okay, and similarly this alkene will be formed if it abstract proton from this carbon atom, and these electrons will shift here and fluoride will remove from here. And one thing is that this is strong base follows E2 mechanism, and it means that leaving group and hydrogen elimination occurs, and leaving group and proton both lies at anti-periplanar position. Okay, and two products will be formed, so one should be major, one is minor, and in this case this is minor product and this is major product. Okay, because this is a strong base, so can abstract this proton from the carbon, which is secondary. Okay, and this carbon is primary in nature. Okay, and if it is abstract from this corresponding alkene, this is a major product. So said this product is major because this alkene is more substituted alkene. Okay, and if we consider four options, in that the major product is second, so C option is your correct answer. Now come to this, we have to know about Jessup rule. Okay, so according to Jessup rule, the major product, the most substituted alkene is generally most stable. According to Jessup rule, most substituted alkene is generally the most stable and thus favored. So this is most substituted alkene, okay, as compared to this, which is mono substituted, and this is di substituted. This is mono substituted alkene. So this is your major product. H2E. Okay, so this is your major product, and this is also known as Jessup product because it follows Jessup rule, and according to that, more substituted alkene is generally most stable. Clear? So C option is your correct answer of this question, in this question. Now come to the 100th question. In this, they asked which of the following substrates don't form trimethylamine as one of the products in its Hoffman exhaustive methylation method. I'm repeating, which of the following substrates don't form trimethylamine as one of the products in its Hoffman exhaustive methylation method? Okay, so first of all, we have to know about Hoffman exhaustive methylation method. So in this method, actually, in this quaternary ammonium salts are formed. Quaternary Ammonium salts are formed in the from amines in the presence of excess of methyl iodide. That's why it is known as exhaustive methylation. Okay, and this method was provided by Hoffman. So it is known as Hoffman exhaustive methylation method. And in this second step, quaternary ammonium salts undergoes elimination in the presence of silver oxide, water, and heating. And finally, in the product, alkenes will be formed, and sometime, if possible, tertiary amines will be formed. Tertiary amine will be formed as a one of the product. So your main product will be alkenes. Clear? So this is known as Hoffman exhaustive methylation method. Clear? And in these reactions, according to Hoffman, less substituted alkene will be your major product. Less substituted alkene will be your major product. Clear? And the main thing is that they asked whether trimethylamine will be formed, and they asked whether trimethylamine will be formed as one of the product or not. Actually, it depends upon the availability of hydrogen atom on the beta carbon atom corresponding to amines. Okay, so if there is a presence of beta hydrogen atom corresponding to amine, in that case, maybe there will be a removal of trimethylamine. So let's discuss. We will understand Hoffman exhaustive methylation using this easiest precursors, that is piperidine. Clear? So first of all, we will draw these structures. One is this, that is first. This is second. And this is piperidine, that is third number. This is fourth. This is fifth. Okay. So first of all, we will understand using piperidine how Hoffman exhaustive methylation will occur. So in the first case, it is treated with excess of methyl iodide. Okay, excess of methyl iodide. So what will happen there? Methylation will occur at this amine, and this nitrogen will get positive charge. After that, you know that in the second step there is also water. So overall this reaction occurs in the basic environment, and base is hydroxyl anion and it will abstract. Now you can see that in the piperidine corresponding to this nitrogen atom, there is presence of beta hydrogen atom at this carbon atom. This is alpha position and this is beta position. So this anion will abstract this proton and these electrons will shift here and these electrons will shift there. So in this way, alkene will be formed. Less substituted alkene will be formed because as in the Hoffman, less substituted alkene will be your final product. Okay. After that, this is exhaustive methylation. So in this, from amines, first of all, quaternary ammonium salts will be formed. But here, still, there is a secondary amine. After that, further, methyl iodide will react and it will be methylated. Again, this nitrogen will get positive charge and this proton will remove from here and then still there is a formation of tertiary amine, right? Now we have to obtain quaternary amine. So this methyl iodide will again react it with it and now quaternary amine will be formed. Clear? So this is your quaternary amine, quaternary ammonium salt. Okay. After that, still, see in this case, there is also iodide anion. So here there is also iodide anion. This is your final quaternary ammonium salt. After that, you can see there is also beta hydrogen in this side. So this is alpha position, this is beta position. So this be again OH negative will abstract this proton. These electrons will shift here and from there final product will be this and one of the product will be tertiary methyl amine. Clear? So in this way, in exhaustive methylation, tertiary amines will be formed or alkene will be formed only if there is a presence of beta hydrogen atom corresponding to that nitrogen. Okay. So in the case of piperidine, tertiary amine is formed as one of the product and that tertiary amine is trimethylamine as one of the product is formed in the case of piperidine. Clear? But we have to answer for that substrate in which there is no formation of trimethylamine. So now we will discuss other substrates. Similarly, if we consider this part, this substrate, you know that there is also corresponding to this nitrogen atom. Here this is beta hydrogen. This is alpha and there is also beta 2 beta hydrogen. In this side there is also beta hydrogen. So ultimately from in this side there will be also trimethylamine as one of the product. So you can try it like this. Okay. And again this OH negative will abstract this proton. Okay. Similarly, after that you can remove this beta hydrogen, this beta hydrogen. So at the end of this reaction, you will get tertiary methylamine as your one of the product in addition to your alkene as your major product. Clear? Similarly, in this case, you can see There is also beta hydrogen corresponding to this nitrogen atom. This is alpha position and this is beta. Similarly, this is alpha position and this is beta. Okay, so in this case, again, tertiary methyl amine will be formed at the end of the reaction in addition to alkene. Okay, now we will discuss these two cases. See, in this case, there is only one beta hydrogen. So in this case, this is alpha position, this is beta. So this is only one beta hydrogen is available in this substrate. But for the formation of trimethylamine, you can see there should be more than one beta hydrogen. So in this case, if there is exhaustive methylation onto this nitrogen atom, clear? This nitrogen will get positive charge and this OH negative will abstract this proton, and here this Hoffman, according to Hoffman, less substituted alkene will be formed, clear? But after this, yes, it is possible that for it can be further alkylated, okay, because there is excess of methyl iodide, and after further alkylation or methylation, it will again get positive charge and OH negative will abstract this proton, and at the end of the reaction, it will be converted into quaternary ammonium salt. But as you can see, there is no beta hydrogen in the left or in this side, because if there will be beta hydrogen, only then OH negative can abstract and this nitrogen can remove here from here as a trimethylamine. Now, reaction will not be proceeded after this step, so this will be your final product, that is quaternary ammonium salt. So in this case, reaction will be stopped on at this stage only. So there will be no formation of trimethylamine in the case of second substrate. Similarly, you can see in the case of first substrate, there is only one beta hydrogen, that is this. Okay. But in this case, there is no beta hydrogen. Clear? So in this case, similarly, reaction will be stopped here. Okay. So this quaternary ammonium salt will be your final product. After that, reaction will be stopped in the case of first also. So in the question, we have to answer about precursors in which there will be no formation of trimethylamine. So according to that, only first and second substrates are valid. So if we choose options, B option is your correct answer in this question. Clear? So in these two cases, trimethylamine will not be formed as one of the product. Clear? In the next question, which of the compounds in pair A and pair B are more reactive towards elimination reactions using sodium ethoxide in the presence of ethanol? So in this case, they are providing you two pairs, and in if you see, all four substrates are decalene systems, and actually these are trans-decalene systems. Okay, and they are using sodium ethoxide in the presence of ethanol, which is a strong base. Strong base and will work under E2 mechanism, and in the elimination reaction, both the leaving group and the proton will lie at anti-periplanar position. Okay, should be at anti-periplanar position. So if we see these substrates in the case in the form of decalin, so this is pair A and B, this is pair. So if we can give number, this is first, second, third, and fourth. Clear? And they are using sodium ethoxide in the presence of ethanol, so which is a strong base, worked in the follow E2 mechanism, and both leaving group and proton should be at anti-periplanar position. Only then there will be elimination reaction. Clear? So if you can see in this case, this bromine, which is leaving group, okay, this is at axial position. This is as axial position, and obviously at this carbon there is one proton which is also at axial position. So sodium ethoxide, your base will obstruct this proton. These electrons will shift here, and from here there will be a removal of bromide anion easily. So if we compare 1 and 2 in these two cases, obviously 1 will be more reactive as compared to 2, because in the case of second, bromine is at equatorial position, but your bromine should be at axial position. Okay, it should be at axial position, and both bromine and this proton should be anti-periplanar to each other so that elimination can occur easily. So in this case, first is more reactive in the elimination reaction as compared to second. Similarly, if we see these cases, in this case, this bromine is at axial position and this proton is at axial position. This bromine is at equatorial position. So obviously in third and fourth, this sodium ethoxide can easily obstruct this proton, and this bromine will leave as a bromide anion from this position, and elimination reaction will be occurred. So if we compare third and fourth, in that case, third is more reactive as compared to fourth. So first is more reactive than second, and third is more reactive than fourth. So if see in options, first is more reactive than second, and third is more reactive than fourth in part. So out of 4 options, A option is your correct answer of this question. Okay. So other questions we will discuss later. And if you have any query or any doubt, any issue, you can write in the comment section. And if you understand anything, you can like, share, and subscribe this channel. Thank you.